Alright, so this is going to be section 4.8, and we're going to use isosceles and equilateral triangles today. So let's start with what it means to be an isosceles triangle. So all isosceles triangles have two congruent sides. Okay, we're going to call those our legs. And then the angles opposite those two congruent sides are base angles. We have special properties with these, but right now let's just be able to recognize those. So our first theorem that we're going to look at is going to be our base angles theorem. Basically what this says is if you have two congruent sides of a triangle, for example you have an isosceles triangle, then we know that the angles opposite those congruent sides are going to be congruent themselves. So here we have side AB is congruent to side AC. So we know that angles opposite those sides, also known as our base angles, are going to be congruent to each other. So here angle C is opposite of our leg AB, and we know that our angle B is opposite of our leg AC. So we know that angle B is going to be congruent to angle C. Okay, so here's going to be your first example. It's going to be pretty simple, but basically we're going to use our base angles theorem to figure out which angles are congruent here. So in this triangle, we know that side DE is congruent to side DF. So our base angles theorem, says that if we have two congruent sides, then the angles opposite the congruent sides are going to be congruent. So here we know that angle E is opposite of side DF, angle F is opposite to side DE. So we know that angle E is going to be congruent to angle F. Okay, so this is going to be our second theorem. It's called our converse of the base angles theorem. So if you remember, converse is going to take our hypothesis of our original statement and our conclusion of our original statement and flip it around. So our base angles theorem before said that if we have congruent sides, then we know our base angles are congruent. And our converse of this is going to say if we know that our base angles are congruent, then the sides opposite of our base angles are going to be congruent, leaving us with an isosceles triangle. So in this picture, since angle B is congruent to angle C, those are going to be our congruent base angles. So we need to look at the sides opposite them. So we know that segment AC is opposite of angle B, and segment AB is opposite of angle C. So we know that AB is going to be congruent to AC. Alright, so here's your example 2. We're going to use the theorems that we just learned in order to find the value of x. So here we notice that angle K is congruent to angle J. So we're going to look at the converse of our base angles theorem, which says if we have congruent base angles, then the sides opposite them are going to be congruent. So here, since angle J is opposite of side KL, we know that KL is going to be congruent to JL since the segment JL is opposite of angle K. So we can set up an equation since these two sides are congruent to each other. See if you can figure that out and solve for x. So since the segments are congruent, we can set their measures equal to each other. So here the measure of KL is 5x plus 5 and the measure of JL is 35. So we can set 5x plus 5 equal to 35. Then it's just simple algebra. So we're going to get 5x by itself, so we're going to subtract 5 on each side, and that leaves us with 5x equals 30. Then to get x by itself, we got to divide by 5, so we divide by 5 on each side, and we're left with x equals 6. Now, since we were asked to find x, we're all done here, but always pay attention to your questions because your questions may ask you to find the perimeter. So if we were to have to find the perimeter, we would plug x back in to 5x plus 5 and get that KL equals 35. And then remember to find the perimeter, we just add up all the sides. So we get 35 plus 35 plus 16, which is going to be, I think, 86. So always make sure you pay attention to the question and answer what it's asking. Alright, so the last two theorems we're going to learn are going to be corollaries to the base angle theorem and the converse of the base angle theorem. Remember, corollaries are just going to be theorems that apply to specific examples. So these are going to look at equiangular and equilateral triangles. So the corollary to my base angles theorem says that if a triangle is equilateral, then we know it's going to be equiangular. So if all three sides are congruent to each other, then we know all three angles are going to be congruent to each other. Our corollary to the converse of the base angles theorem says that if a triangle is equiangular, then it is equilateral. So if we know that all of my angles are congruent, then that means I'm going to be left with all of my sides being congruent. Alright, so here's our last and third example, and we're going to use all of the theorems that we've learned today. So let's start off with first trying to understand what our question's asking. So we want to find x and y. X is going to be the measure of the angle of ABD, and y is going to be part of the length of our segments BD. So the first thing we're going to have to do is let's first look at our equiangular triangle. So noticing the arcs in triangle ABC, we notice that all of our angles are equivalent. So if all of our angles are the same or they're all congruent, then we can use a corollary to the converse of the base angle theorem that says if we have an equiangular triangle, then we also have an equilateral triangle. So we can say that all of our sides are going to be the length the same, they're going to be congruent to our side AC, so we can say all of the sides of our triangle ABC are going to be 40. So that means that our side BC is going to have a length of 40 also. So once we figure that out, we can decide what kind of triangle BCD is going to be. So since we found out that BC was 40, we know that BC is congruent to CD, since CD is also 40. So now we can use our base angle theorem, which says if we have two congruent sides, then the angles opposite them are going to be congruent. So since BC is congruent to CD, we know that angle CBD is going to be congruent to angle CDB. So we know that angle CBD is going to have a measure of 30 degrees. So we found part of the angle of angle ABD. So we found part of what x is going to be. Now we need to figure out the other part. So now let's go back to triangle ABC. Since we knew that our triangle was equiangular, we know that all of the angles must be the same. So let's say that the measure of any of our angles in this triangle is going to be y, just some variable. It doesn't matter what variable we use, I just don't want to use x since x means something else. So if we set all of our angles equal to y, then we know that our triangle sum theorem says that all of our angles in a triangle must add to 180 degrees. So we can say y plus y plus y equals 180. Now we can simplify and figure out one of our measures in there. When we simplify, we get 3y equals 180, so we need to divide by 3 on each side and get y equals 60. Now, something that you can remember is if we have an equilateral triangle or an equiangular triangle, my measure is always going to be 60 degrees, because 60 is the only thing that I can multiply by itself or add to itself 3 times to get 180 degrees. So if you can remember that, then I won't be looking for this step in your work. But if you don't remember it, then that's just an automatic wrong answer. Alright, so now our last step in order to figure out what x is going to be by using our angle addition postulate, because we know x is the measure of angle ABD. So our angle addition postulate says the measure of angle ABD is going to be the measure of the angle ABC plus the measure of the angle CBD. So we can go in and set up our equation that says x equals the measure of angle ABC plus the measure of angle CBD. Then it's just simple substitution and then plugging and chugging. So then we get x equals 60 plus 30, since the measure of angle ABC we found to be 60, and we found that the measure of angle CBD is 30. So then we simplify and we get x equals 90. Alright, so we found x, now it's time to find y. So when we found x, we got that x was 90 degrees. So we know that the measure of angle ABC, or I'm sorry, ABD is going to be a right triangle. So if we plug in everything we know so far, we know that the side AB is 40 degrees over here, since we know that that was part of our equilateral triangle. So since we have a right triangle, we can use our Pythagorean theorem. So we have a squared plus b squared equals c squared, where a and b are sides of our right triangle, and c is going to be our hypotenuse. Remember, the hypotenuse is going to be the leg right across from our right angle. So when we plug it in, we get 40 squared plus 8y squared plus 40 plus 40, since that makes up c. So when we distribute our squares, we get 40 squared is going to be 1600. 8y quantity squared is going to be 64y squared. And then we simplify in our parentheses and we get 80 squared on the right hand side of our equal sign. So then we can simplify that even more and get 80 squared equals 6400. Now our job is to get y by itself. So we subtract 1600 on both sides and get 64y squared equals 4800. Now in order to get y squared by itself, we have to divide by 64 on both sides. So we're left with y squared equals 75, and then the opposite of a square is going to be to take the square root. So in order to get y by itself, our last step is going to be to take the square root of 75, and we get y equals 8.66.